Hello everyone. We excited to present our project on car price prediction using machine learning. In this presentation, we will compare several machine learning models to determine the best one for accurately prediction the price of used car. The model we will use range from simply approach like a linear regression to more complex methods like random forest. Let's begin. Next, problem statement. The used car market is growing fast, and deciding the right price for a car is challenging for both seller and buyers. Unlike a new car, the price of a used car can vary depending on various factors, such as the car age, brand, condition, and even market demand, which makes pricing subjective and difficult to estimate. This is where machine learning can help. The objective of our project was to develop a machine learning model that can predict the price of used car accurately, taking into account the different factors that influence car selling price. Next, dataset overview. To build this prediction model, we use dataset contain various features of used car. These features include basic detail like the car name, year of manufacture, present price, selling price, and kilometers driven. Additionally, dataset contain inform, information about the car's fuel type, transmission, owner type, mileage, engine size, maximum power, and the number of seats. The target variable that we try to predict here is the selling price of the car. All these features were carefully chosen. They are some of the most relevant factors when determining a car price. Next, data preprocessing. Before jumping into the model processing, we need to preprocess the data. The first step was to handle missing values. Some features had missing entire, which could lead to incorrect model. So I fill in or remove those missing values. After that, I had deal with qualitative data. Feature like fuel type and transmission are not numerical, but machine learning model require numerical data. So I applied one-hot encoding to convert them into numerical format. I also had to extract numerical value from text-based column like mileage and engine size. This step ensured that all the data was in format that could be processed by machine learning. We broke the dataset into training and testing set. This division crucial because it allows the model to learn from one set from data and be test one unseen data, simulating real world performance. Next, I would like to invite Possibly continue the presentation.
Thank you, Nil. Now let's move on the models we use for predicting car prices. We experimented with six different machine learning models. Number one, linear regression, a simple but powerful model often used as a baseline. Number two, random forest regressor, a robust ensemble method that can handle complex datasets as well. Number three, bagging regressor, another ensemble technique that reduce variant and overfitting. Number 4. Gradient boosting regressor. A boosting algorithm that focus on reducing bias and improving model accuracy. Number 5. Decision tree regressor. A tree-based model that works by splitting the data into smaller segments. Number 6. K-nearest neighbor. A non-parametric method that makes predictions based on the similarity between data points. These models were chosen because they offer a range of complexities, allowing us to evaluate their efficiencies in predicting the car prices. Model evaluation metrics. To evaluate the models, we use several key performance metrics. First, we look at cross-validation scores. Cross-validation helps us to understand how well the model generalizes to unseen data, which is important to avoid overfitting. Next, we compare the training score and testing score for each model. If a model performs very well on the training data but poorly on test data, it may be overfitting. We also used R-squared score, which tell us how well the model explain the variance in the data. In R-squared score, Closer to 1 indicates a better fit of the model to the data. Let's take a look at the results. This table compares the performance of each model based on the R-squared score, which means how well the model's prediction match the actual prices. As you can see, the models vary in performance, with some doing better than others. We will walk you through the best performing model in the next slide. Among all the models, the random forest regressor performed the best with 97% R-squared score, which is a very high accuracy. Random forest work by combining multiple decision trees to reduce the variance and increase prediction accuracy. This model showed great generalization ability, meaning it performed well not only the training data but also on the test data, which is crucial for any real-world application. The random forest model high cross-validation score also indicates that it can adapt well to the new data. This makes it the most reliable model among those we tested, and it is the one we would recommend for predicting car prices in practice. With that, I would now like to hand over to Deshan, who will continue with the next part of the presentation. Thank you.
Thank you, Pasindu. Discussion key observations. There are a few key observations worth mentioning. Linear regression performed the worst with an R-square score to only 68.83%, while simple and model couldn't capture the complexity of the relationships between the car features and the selling price. Discussion trees shows sign of overfitting with the very high accuracy of 99.97%, but much lower test accuracy. This suggests that the model was too specific to the training data and didn't generalize well to unseen data. Random forest, however, was able to balance accuracy and generalization, which is why it performed the best overall. It didn't overfit and was able to predict car prices accurately on the test data as well. Limitations. While the model performs well, there are several limitations to keep in mind. First, the model doesn't consider real world factors. For example, band repetition and car history couldn't play a major role in pricing, but these factors were not included in the dataset. Second, some models, particularly decision trees, tend to overfit the data. Overfitting means the model becomes too specific to training data and doesn't perform well on new data. Finally, we didn't explore deep learning models, which are often used for more complex tasks. These models might have led to even better prediction, but they were outside of the scope of this project. Thank you. I invite Vasida to continue our presentation.
Thank you, Deshan. Future improvements. There are several ways to improve this model further. Feature engineering is one area where we see potential. For example, we could add more relevant features such as the car's condition, the brand's reputation, or even external factors like market trends. Another area for improvement is hyperparameter tuning. This involves adjusting the settings of random forest model to find the optimal configuration, which could lead to even better results. Additionally, we could experiment with stacking models where I combine the prediction of multiple models to improve overall accuracy. Finally, exploring neural networks and deep learning models could potentially lead to even more accurate car price predictions, especially when dealing with large and complex datasets. In conclusion, this project aimed to develop a machine learning model for predicting car prices. After testing multiple models, random forest engaged as the best performer with an impressive 97.03% accuracy. While this model performs well, there is always room for improvement through better feature engineering, hyperparameter tuning, and the exploration of more advanced techniques like deep learning. Overall, this project has demonstrated that machine learning can provide high accurate car price prediction, which can be beneficial for both buyers and sellers in used car market. So thank you for your time and attention.
Now I would like to invite Rajendra to continue with the next part, which is the demonstration.
Thank you, Vasudev. I am excited to demonstrate the car price prediction app built using Streamlit, which utilizes a random forest model to estimate car prices based on various features. This app takes user inputs like brand, mileage, fuel type, transmission, and more, then predicts the price using a trained machine learning model. First, let's start the application. I run the following command in the terminal. As you can see, the app has a clean and interactive interface. Let's go through the main sections. At the top, we have the car title. We have the title, car price prediction, along with a brief introduction to how the app works. The app provides drop-down menus and sliders for users to enter details like brand of car, type of owner, transmission type, type of fuel, type of seller, kilometers driven of car, mileage, age of car in years, engine of car, max power of car in horsepower. On the sidebar, we have a predict price button which runs the machine learning model and provides an estimated car price. Now let's enter some sample data and predict the car price. Let's click on predict price. As you can see, the model predicts the price of this car as 18 lakhs 634 rupees. Now let's try another vehicle. Let's click on predict price. The model predicts that the price of this car is 59 lakhs 26,457 rupees. Let me explain how this app predicts the price. The app collects user input through the form. Then it converts categorical data into numerical values. The data is passed to a pre-trained random forest model which makes the prediction. This is the best model. The result is displayed in a formatted price. So this app is highly accurate, achieving a 97% prediction accuracy. In the future, we can improve it by adding more car brands and models, enhancing the model with real-time price updates, and integrating an API for live car price comparisons. That concludes my demonstration. Thank you for your time.